Hi, I'm Christian.
And I'm Vera.
And today we want to talk about things you may not know about your drive shaft. Today we want to talk about drive shafts and see if there's something you don't know about them. I mean, what can some German dude and his wife tell you hardcore overlanders about a drive shaft you may not know? So that's a challenging task, especially if Vera is going to answer the question.
Oh man.
Here, look down here, I made a sketch and I explained Vera the basics of driveline. Okay, the reason we had to take this drive shaft out of our Discovery was this center bearing failure here. It's actually not the bearing what failed, it's the rubber which completely is gone and it's just bouncing around. It could be already like this forever, we don't know.
And we would have never found out about it if we hadn't taken the heat shield off.
We had to take the heat shield off for other repairs and that's when I saw it. We're gonna replace now a genuine OEM GKN drive shaft which is in the vehicle for 220,000 kilometers and it has absolutely no play in the joints. It just has a disintegrated center bearing with the cheapest possible prop shaft available on the planet, made in China. Okay, see here? We look at the drive shaft. It's a two-piece with one CV joint, two CV joints, and a universal joint. So what does that CV joint, what does that CV stand for?
Constant velocity.
Okay, remember I gave her here a training class on this whiteboard, okay? So in this application we got a plunging CV joint. Why is it plunging? What's it doing there?
Oh, it's moving.
It's moving in and out in addition, versus the universal joint obviously can't do that. And we got a second, we got a second plunging CV joint. So far these two drive shafts are set up exactly identical, there is no difference. Now here is the major difference of those drive shafts. Okay, so we'll see. That's the OEM drive shaft.
And it says?
93.
Wait a second,
0.0.
Yeah.
93.0. And now the new one. Okay.
So
94.2.
94.2.
1.2 kg heavier. Okay, now you get on.
No, I'm not going to get on.
What was it?
1.2 kilos? Yeah.
1 point some kilos heavier. And the thing is, it got the same joints. Everything is the same. You know, even the joint on the OEM looks a little beefier. Even so it has the same cross diameter, it looks a little beefier, but still, this drive shaft is 1.4 kg heavier. So where is that weight?
And the thickness of the wall.
The tube wall thickness is the major difference between these drive shafts. And you wonder now, well, is it better or worse having a thicker tube material? And I tell you something, check this out. And check this out. Okay, so the most expensive thing for an OEM to manufacture a drive shaft is to keep the weight low. Any kg of rotating mass in a fast rotating drive shaft is a downside in the response of the vehicle and also from the CO2 emissions. So they will do anything, even back in 2006, to keep the driveline light. Making thin wall drive shafts is definitely far more expensive than thick wall tubing drive shafts. Now remember, we are in the OEM business, not in the off-road business where you have these custom made by your drive shaft experts in your local shops. That's a different story. You got a different kind of a goal. You want to have a rugged drive shaft. A Discovery drive shaft is a special application. What's that application called?
I don't remember.
It's installed in a non-articulating fashion. So it's a non-articulating application. That drive shaft is running like a drive shaft in a sawmill between a stationary engine and a stationary machine.
It's mounted straight.
It's mounted nearly straight in that application, and it is not articulating like when you run your heavy-duty drive shafts, off-roading, driving your rear axle, and your rear axle is articulating up and down, and that's a whole different application. But still, even you guys putting in aftermarket drive shafts, you do a lot of trade-offs. And those trade-offs are important to you. You want to get durability over driving comfort. You want to get durability over gas mileage. Your goal is to have a drive shaft which will not fail. And the trade-offs are definitely comfort and gas mileage. And on a luxury car like the Discovery, they had a completely different goal. They wanted to keep the gasoline consumption as low as possible and the driving comfort as high as possible. And they did not really fail on the durability.
No.
It's just that stupid center bearing what gave up.
And we didn't even feel it in the driving comfort, you know?
Yeah.
There was no obvious.
No, there was no obvious. But we put a camera below the vehicle and we looked at the we looked at the center bearing, what it's doing on road conditions, and we put some footage in here. And man, it sure convinced me I gotta replace that center bearing. So that's the reason it's on the table now. Okay, so we want to go over differences. The welds. It's way easier to produce a MIG weld than it is to produce this magnet arc weld. This magnet arc weld is produced by running an inductive field around this tube really fast, making that section glowing, and when it's red glowing all the way around, a hydraulic press will press that tube onto that forge piece, all in one process. This is how this is done. Versus on the MIG welding process, it's like you guys all know it from your drive shaft manufacturing shop around the corner. It's running a wire driven MIG welding application into one side, and then it's rotating the drive shaft, producing the speed. This process here will produce a certain runout, which later on needs to be straightened. It causes this tube requiring a straightening process. This is done by your driveline expert around the corner by heating it up in certain sections and then bending it down. And he does that with his years and decades of experience, and he can actually get that drive shaft with a really low runout. But the OEM can't. The OEM doesn't have time, and they have, one time this worker on the line and another time this worker on the line. They can't afford an expert straightening this. So they need a process which will produce a seam here and there which causes zero runout. And the way they do this is they use the magnet arc process, and it pushes it all on in one process. And they can control the overall runout just by doing this in a very expensive and straight machine. And it's faster. And it's able to process thinner tubing material. Try to weld a thin wall onto a forge piece, you know what I'm talking about. This is just not so easy done. That's why they increased the tube size here. They don't care about the weight, the Chinese. And this makes the drive shaft then heavier. Versus the OEM wants to keep that weight low. Yeah, I bet this is a 1.6 millimeter material. And I bet that this is a 2.2 millimeter material. But we won't saw it open now.
Oh, I hope not.
Okay. So they got away using one universal joint, which is not a typical application. It says to the user, this drive shaft got to run in a straight line. If we would run this in an angle, in any kind of articulation, it would develop a non-constant velocity on this joint, and it would not be compensated down the line, down the drive line, because there is no second U-joint.
Yeah, what about Dirt Lifestyle's Land Rover?
Well, he's got solid axles.
Oh, he did that swap.
He did a solid axle swap.
And then you have...
when you use U-joints, you have to have two U-joints. And of course...
And here too?
Well, he's probably using a single-piece drive shaft. So he has...
I think it's unnecessary to have all that junk here.
Okay, then explain us...
You need that and that.
Yes, then explain us why did the manufacturer, the driveline engineer, use a two-piece drive shaft instead of a single-piece drive shaft?
Because the owners are so sensible and they feel every little bit of discomfort.
Okay, you take the camera.
but
This was definitely the female explanation, okay? Something about the owners not feeling. What did you say? Okay,
They are so sensitive.
I'll explain you why.
And I don't mean us girls,
Yeah. Now the big question is...
Now. Yeah.
The big question is, why did the driveline engineer not simply put a single piece drive shaft into this application? It's a non-articulating application running in a straight line. It doesn't seem to be that difficult. A Ford F-150 easily has a 1.3 meter drive shaft in a single piece application. And the question is, why did he not do that? He would have saved a lot of money. CV joints are way more expensive than universal joints for a manufacturer. Okay?
Yeah.
So why did he do that? Well, the reason is very simple. It's weight. Weight and also volume. He needs to get the drive shaft into a certain dedicated space in the vehicle. That space is assigned very early on in the project. There is the muffler. There is the gas tank. There are components in the way. This space he has available, he has to fill with a drive shaft, which is doing the torque and the RPM. And of course the articulation, which is not a big problem here. But the torque and the RPM, he's got to get down into that area, not exceeding a certain weight, which was also spec'd out to him, given very early in the project. And he has to meet that. He cannot get a approval to simply increase that weight like you would do when you upgrade your driveline to go off-roading. You don't care about that. But he has to meet those criteria. And now, when he wants to put in a single piece tube to cover this entire span, something happens. He doesn't have the room to go big, so he will change his resonance frequency of his tube by making it longer to go
down.
Exactly. The resonance frequency of his tube will go down as it gets longer. We all know that.
Yeah.
When I ring on this tube and it's longer, the sound will go down. If I make this tube shorter, just like the string on the guitar, and you ping on it, the pitch will go up. This is a different thing when I hold it here, but on your guitar, you hold the string shorter. What do you call this?
I don't know.
You do that,
Yeah.
pitch will go up. Same on a drive shaft tube. So if he makes that tube longer, pitch is going to go down. That drops the resonance frequency of that tubing down towards his maximum operating RPM. And when a drive shaft gets closer to the operating speed, the resonance frequency of that tube gets closer to the operating speed, the drive shaft will develop, it will get excited, and it will develop vibration. It goes as far that when you run it into the operating speed, that the drive shaft will burst. So the manufacturer has to do everything to keep the resonance frequency of his tubing above the operating speed. And remember, the car, the Discovery, is rated for 180 kilometers per hour. So that's a fast spinning application. This is also quite a gear ratio in the back. So you get here into RPMs of 6,000 to 7,000, probably 6,500. So that's why they did not put one straight tube in. Now they could have made this tube now bigger, like in a Ford F-150, in order to get that stiffness back, in order to drive the resonance up, or they could have made it heavier, thick wall. That would have also driven the resonance back up. But what did we say?
Rotating mass is no good.
Rotating mass is no good.
I mean, if it's increasing.
He had a boundary on the area where the drive shaft is mounted. He had a boundary on the weight. And that left him no choice. He needed to split the drive shaft into two pieces. And he also had a slight alignment problem in the vehicle caused by the components around.
Yeah.
So this drive shaft in the vehicle actually does have a slight 2.3 degree angle.
Yeah.
Okay. It's straight down there. That's why it developed the notching.
And a drive shaft is always steel?
No.
It's not.
This one is a steel drive shaft.
Both of them.
Yes, both of them.
Yeah.
But you can have an aluminum drive shaft, like the Ford F-150 and some other big American pickup trucks have aluminum drive shafts. The tubing is then up to 5 inches in diameter. But aluminum is expensive. It's expensive to manufacture, and if they can get away with a steel drive shaft, they will always put in a steel drive shaft. Aluminum drive shaft is significantly more expensive.
So the Range Rover has an aluminum.
And more difficult to manufacture. I don't think any British vehicle has an aluminum drive shaft. I think you find that only in American pickup trucks, but I'm not sure.
Yeah.
Yeah. So this is hopefully some information you did not necessarily know in this context, like putting in such a complicated drive shaft, if you could get away typically with a one-piece drive shaft, okay? And what I want to check now is the fit. The fit is the first thing where I expect a certain problem. 65, it's really 65.26.
Okay.
And this is 64.99. So it's missing 0.25 millimeter in diameter on a close fit.
It doesn't sound that much.
This was a press-in fit. So if we're missing 0.25 millimeter on a press-in fit,
it's gonna be loose.
It makes that drive shaft a reject. This is not usable for an OEM. The OEM would have to trash that drive shaft because with this poor fit back here, he can't control his unbalance when he puts that drive shaft on. The drive shaft is not running on the true center line. It will be slightly off by how much?
Yeah, 0.25.
No, by half of that, because it could be in the center, it could be upper, it could be lower.
Yeah.
So it will be off by 0.13 millimeter if it slides over to one corner.
But in my world, it's also really tiny.
Okay, it's really tiny. I tell you what that does. We know it's a difference of 0.2, what did we say? 6 millimeter.
We should check that again.
In diameter, okay? That's the difference. Now what will cause this is if you have now the operating line of this drive shaft, yeah, here, and there's your joint, and here we have our fit. What will happen now if I exaggerate this now and I bolt this fit onto the axle flange, this one is smaller, it actually looks like this, yeah? So this is our fit, and this is our axle flange, yeah? So there is a gap here, this gap, and this will cause the center line between here and here to have an offset. So it's this offset between here and here. Does that make sense?
Yeah.
And this offset can be as big as 0.13 millimeter. You know, when I tighten those bolts up.
Yeah.
It could be. And this is an absolute no-go for the manufacturer. And the reason this is very simple. He has to maintain a certain unbalance in his driveline. And the spec on an SUV made in Europe for the entire driveline unbalance per plane, we talk about balancing in planes, wherever you have a joint or a mating surface, that's a plane. You can see here the correction weight for this plane, and you can see here the correction weight for this plane to compensate the unbalance, and then here for this plane. So they need to maintain 250 to 350 gram millimeter of maximum unbalance. Gram millimeter is the unit of unbalance, or in the US, ounce inches. I'm guessing this a little bit, but I'm pretty sure I'm somewhat accurate. And now what they got to do with this fit here is to keep it as small as possible, because now you take the weight. So if you put a scale on here and you measure that weight in kg, yeah, that is the weight applied working here times that radius, that gets you gram millimeter, gram times millimeter. So we got to know the weight of this drive shaft end times that 0.3, and we got the amount of unbalance which we will introduce only by that fit. We'll measure that weight.
Really?
I got to put a kind of like a bias weight on it. It reads 5.9, can you see this? 5.8, and now I increase the weight. So it's 5.8 to 9. 5.8 and 9 is the second reading. The difference in between is the weight of this drive shaft. See how it, over here? See how we only measure this applicated end here. So now the difference in between is 3.2 kg. And what I need to do now is I take the 3.2 kg, which is 3,200 grams, times our 0.13 millimeters of potential runout, and the result is this fit alonely will cause us an unbalance of 416 gram millimeter, which is already higher than the manufacturer wants to have in a total. And in reality, we have to add to this unbalance also the unbalance we still have left in this drive shaft here at this location, which we set on the cheap Chinese one. This is probably whatever, 200 gram millimeter. This is the best they can do. So if we add this unbalance to this unbalance, depending on the vectors, on where the unbalance is located, it may add up, it may subtract. But in the case where it adds up, we end up with a complete sum of 616 gram millimeter potential unbalance. And anything over 300 you can feel in the car. So this is terrible. And this is, but we're going to run it first and try it. Because we may get lucky here, you know, and then everything's fine. But it's heavier and it has a poor fit. The fit on the other side, I would assume, let's just do what we got here. So I measure 99.46 in direct comparison. And on this OEM, 99.41. So that's 200ths of a millimeter potential, you know, offset. That's okay. So we take 0.02 times, plus this end is lighter. It's probably 1.5 kilos, 1,500. So we got only 30 gram millimeter cost by this run out. So that side is fine. But this side is a complete debacle. I think that's it for this video, right? Unless
no, I want to show them the problems it caused.
The problems.
So we have here some, what do you call it?
Oh yeah, okay. So we got here, you're right. Oh man, good that I have you here. We got here these rub marks.
Rub marks,
okay.
Exactly.
These rub marks really were caused by this center bearing not holding the drive shaft in the correct position anymore, and the drive shaft started to rub here actually on a cable.
Exactly. And
rubbing on a cable in a Discovery is no good. It's already no good if nothing is rubbing. So this was close. The cable was kind of protected with one of those plastic-ish protection wires, and it rubbed through, so it got to the isolation of the cable. So I think that would have been a matter of time, and we would have lost, I think, our gas gauge maybe the ABS system. It could have been a wire of the air suspension valves in the back.
And that would have been. And we would have never looked underneath the drive shaft.
No, because this was below the heat shield.
And I always wonder why, I mean, also expensive car, break down on the Autobahn, you know? And now I know, because of shit like that.
What do you need?
Oh, he wants to show his barbecue.
Oh, you made a barbecue fork?
You know, so you can...
Oh, wow.
What is it called?
This is nice. Like it.
Yeah.
Yeah, I'm just gonna go grind these tips.
Yeah.
So...
Now here...
Yes.
Yeah, but we need a few more minutes. Then he wants to use the grinder over here. So now, what did you want to explain? Was broken down cars on the Autobahn?
Yes, because I always wonder why is there breakdown?
Because they never look under their heat shield.
Yes, but when I'm gonna break down because of shit like that.
Shit like that's a swear word. I have to put a beep over this. So
yes, but stuff like that stresses me out completely. You know.
Well,
and now a Chinese propshaft. I'm never gonna go on the Autobahn again.
One more thing I wanted to tell you. We were talking gram millimeters, and for you guys over there in the States, so the 460 gram millimeter is actually 460 divided by 72, I think. No, by 720. So this is 0.63 ounce inches. Okay, I know you guys work in 0.63 ounce inches of unbalance. Next time, when you in your driveline shop and you have your driveline made up by this expert, ask him what his balancing spec is in ounce inches. Okay, see what he can get it down to on his Westport balancer. And I bet you he doesn't even know, because he doesn't have a way to measure that. So this is why a real drive shaft from the OEM is I'm sorry. Okay, there it is. Yeah, this is a GKN drive shaft. This is why this drive shaft is just far superior in terms of running comfort, and maybe not in durability, but running comfort is absolutely unbeatable. And this is a mass-produced product, okay? I think this is now it for the video, isn't it?
No, we still have to mount it.
No, we make that in a separate video. This video was called Things You May Not Know About Your Drive Shaft.
But
okay?
I'm going to call it drive shaft or propshaft. So that's about it. I did more than I can handle, actually.
Okay, that's it for this video. I hope there was indeed something you didn't know about your drive shaft.
Yes.
And if you enjoyed this video, go hit that like button and maybe even subscribe, or at least if you're already subscribed, don't unsubscribe. Okay, see you guys next week.
See you next week.